We're going to find the zeros of this polynomial right here, and we're going to kick this off by getting out our graphing calculators and entering this polynomial. So here I've pressed this y equals button. I use this to put the x's in. I use this to put the powers in. I'm going to press graph to get a good start and look for places where the graph hits the x-axis. Looks like it hits over here at positive 4. Which makes sense because positive 4 is a factor of this constant, so I'm not surprised to see that's a number that does that. Setting up my synthetic division with that 4 on the outside, I've got a 1 for the x cubed, negative 4 for the x squared, 4, and then negative 16. This first number drops straight down. We'll multiply these together, put that answer here, add these together, put that answer there, multiply 4 times 0 is 0, add these together, 4 plus 0 is 4. Multiply these together to get 16, add these to get 0 as expected. And this is a little bit new. We haven't seen a 0 in the middle before, but it's not going to bother us. Nothing really changes. This 1 represents x cubed, so this represents an x squared. There are no x's, so I'm not even going to bother writing 0x, and then this represents 4. So now we do want to find the zeros of x squared plus 4. Where does that equal 0? This is not one I could probably just look at and figure out necessarily. It does involve a new concept, and the best way to get the zeros of this is to get this x by itself, and I'll do that by using reverse PEMDAS. I can get this x squared by itself if I start by subtracting 4 from both sides. That would give me x squared equals negative 4. And then we can square root both sides, and what we learned in last chapter was if you have a negative number under a square root symbol, there's no real answer, but we can definitely take the square root of 4, which is 2, and because it's negative, I'll put that imaginary unit of I on there, and because I put the square root in there, I've got to put a plus and a minus and my final answer. So my complete set of zeros is going to be the 4 that I got off the graph and the plus and negative 2i that I got by solving. I do want to point out that these numbers are imaginary numbers. They're not real numbers, which is why when we had the graph, we didn't see that graph hitting any other place on the x-axis. These numbers aren't on the x-axis anywhere. This x-axis is only for real numbers. So there are going to be these imaginary zeros, and we do have to include them in our answer, but the only way to find them is by remembering how to solve a quadratic where you can get the x squared by itself and isolate. Good luck, my friends.